I'd like to introduce three temperature scales for us to try to understand that some of them we're fairly familiar with. We're not going to work on really converting the scales in this video. That's a little complicated, and we'll do that in another video. But today we're just going to introduce these three scales to you. The point about all three of these scales we want to look at is the boiling point of water and the freezing point of water. We're going to measure these on all three of these scales, and it's something that you should probably memorize and know what the freezing point and boiling point of water is, because later that's going to help us to be able to convert between different types of scales. So the first scale that we want to look at is called the Fahrenheit scale. It's one of the oldest scales. It was 1724 by Daniel Gabriel Fahrenheit. And ironically, it's still a scale that the common person will still use. If you're listening to the weather and you want to know what the temperature is going to be out on every day this week, then they're going to give you that temperature in Fahrenheit. It's something that we're just kind of used to, and therefore we haven't kind of really gone on with metrics. So we're still kind of stuck on the Fahrenheit scale. If you look at on the Fahrenheit scale, we see the freezing point of pure water is 32 degrees Fahrenheit, 32 degrees Fahrenheit, and the boiling point is 212. It's kind of bizarre. We just kind of have these this range of degrees Fahrenheit, and it's kind of confusing on exactly what Daniel Fahrenheit was trying to do when he came up with these particular numbers. People say that he had 0 degrees Fahrenheit was the freezing point of like a saltwater solution. But anyway, we have this range from freezing to boiling, and if we subtract 212 minus 32, we get a range of 180 degrees of Fahrenheit difference between freezing and boiling. So that's going to be important later. We want to have the difference in temperature between the freezing and the boiling points of these things. So Fahrenheit's scale, boiling was 212 degrees Fahrenheit, freezing is 32 degrees Fahrenheit, kind of hard to remember those. The difference between them was 180 degrees. So a little while later, 1744, we have a person by the name of Anders Celsius, and he came up with a little better scale, kind of a metric type of a scale. And he had freezing at 0 degrees Celsius and boiling at 100 degrees Celsius. So we have 100 degrees Celsius and for boiling, the boiling point. And the freezing point was 0 degrees Celsius. And so the difference between freezing and boiling we see is very easy to remember, 100 degrees. That's why actually when we write the degrees C, a lot of people think that that's Celsius, and we kind of sometimes do call it Celsius, but technically, just for your information, it was really called centigrade. It's instead of the Celsius scale, it just happens to be that they both start with C. It's kind of a strange thing. This is actually called the centigrade scale, centa meaning 100, and grade or graduations means steps or degrees. So centigrade, the centigrade scale means there's 100 steps between freezing and boiling point. This is the centigrade scale. So this kind of made it more into a metric type of a scale. Really, for whatever strange reason, I kind of didn't quite tell the truth. Celsius, he actually had this flipped. It was kind of strange. He had 100 degrees Celsius as the freezing point, and then as it warmed up, it went up to 0 degrees Celsius for the boiling point. It was kind of strange. People weren't really sure why he did that, and after he died, some people just flipped the scale around to be kind of more normal. So the centigrade scale, the Celsius scale we use today, the freezing point is 0, and the boiling point is 100. So that's a little easier to remember that particular scale, and we use that in science a lot. Our third scale is an 1848 by William Thomson, and he kind of went by the title Lord Kelvin. So we have this Kelvin scale, and you'll see on here the boiling point is 373. It's 0.15, we just kind of usually forget about that part there. 373 Kelvin, and freezing is 273 Kelvin. And you'll notice that there's no degree symbol there. Kelvin called his degrees Kelvin. So it's 32 degrees Fahrenheit, 0 degrees Celsius, but it's 273 kelvins. There's no actual degree symbol there. A Kelvin is what he called an interval or a degree. Anyway, the freezing point was 273, and the boiling point was 373 Kelvin. And you might ask, how come these big numbers? Well, Kelvin was he came up with a pretty intelligent scale. He was discussing what temperature actually is, and temperature actually is a measure of the kinetic energy of these particles are moving around real fast and bouncing off of each other, and the faster they move, the more kinetic energy they have, the higher the temperature. So temperature is just a measure of kinetic energy, and therefore Kelvin was thinking, that means that how slow can these things move? If you keep slowing them down and get a colder and colder temperature, there would actually be a limit. I mean, eventually you can't move any slower than stopped. So Kelvin said that eventually these particles would cease to move at all, and therefore that would be a lowest possible temperature that we could get. And so he set his scale to have a minimum value of 0 Kelvin. He didn't like negative numbers, and so his scale has no negative numbers because the slowest you could possibly move would be 0. And he assigned that place as 0 Kelvin on his scale, and he called that absolute 0. It's called absolute 0. And so there are no negative numbers. So if we set that at absolute 0, and Kelvin was also smart because he wanted, a lot of people used the centigrade scale by this time, and he wanted people to be able to easily convert from Celsius or centigrade to his scale so that people would use his scale. He equivalated 1 Kelvin to equal 1 degree Celsius. So that's why he got the numbers that he has. 0 Kelvin, he goes all the way up to the freezing point of water, which is 0 degrees Celsius. That on his scale would equivalent to 273 Kelvin. So you'll notice the difference between freezing and boiling on the Kelvin scale is 100 kelvins. On the Celsius scale, it was 100 degrees Celsius, and so that difference between freezing and boiling was the same for both Kelvin and Celsius, which is going to make it in the next video a lot easier to convert from Kelvin to Celsius or Celsius to Kelvin, rather than converting from Fahrenheit to Celsius or Celsius to Fahrenheit. So those are our 3 scales: Fahrenheit, Celsius, and Kelvin. And the freezing and the boiling points, you need to memorize on those and know the difference between them. So the difference between Fahrenheit was 180 degrees of Fahrenheit. For the difference between Celsius was 100 degrees of Celsius, and also 100 Kelvin on the Kelvin scale. So hopefully that will help you kind of have a nice introduction of your temperature scales, and in the future videos we're going to learn how to try to convert between these 3 things.